Let's try another one of these, and I'll see if I can avoid those mistakes along the way. This time, I want to integrate cosine to the power 5 of x dx. Just like my previous problem, I have cosine raised to the 5th power, but I can't use a u substitution because I don't have any sines. So once again, I'm going to use my trig identity. I know that sine squared of x plus cosine squared of x always equals 1. It is cosines which I have in my integral, so I'm going to rewrite this formula to say that cosine squared of x is equal to 1 minus sine squared of x. Let's see what I can do here. My integral, how many cosines do I have? I've got 5 of them multiplied together. Can I pull out 2 of them? Yes. Can I pull out 2 more? Yes. Can I pull out another 2 more after that? No. So if I'm trying to pull out a cosine squared, which is then raised to the power 4, to the power 2, I wrote the correct thing. That's a good start. Cosine squared of x squared is cosine to the power 4. I need 1 more cosine of x to go along with that. And that's actually looking good, because now the most nested part of my problem, I claim, is actually the sine function. Let's do the substitution to make that more apparent. Cosine squared of x is equal to a 1 minus sine squared of x. And this time it is raised to the power 2. And then multiplied by cosine of x dx. And just as I claimed, the most nested part of this function is the sine function. This time I do have the cosine of x dx here. I am perfectly set up for a u substitution. So if u is equal to sine of x, then my differentials are going to say that du is equal to cosine of x dx. What does that mean for my integral? I have 1 minus u squared raised to the power 2 times du. Hey, I didn't even need to worry about a minus sign this round. Now, in order to integrate this, I'm going to expand out my polynomial in the variable u. Of course, I make a mistake somewhere. But that's okay as long as you catch it. When I expand this out, I'm going to have 1 squared minus u times 1, 1 times minus u squared. And the square of a negative number is positive. All of this du. So what is that simplified? 1 minus 2u plus u squared. Integrate with respect to du. My antiderivative is going to be a u minus a u squared plus a u cubed on 3 plus my constant of integration. And the very last thing I need to do, the problem was given to me in x variables. The answer needs to be in x variables. My u is equal to a sine of x every single place that u appears. So the answer to this problem is going to be sine of x minus sine squared of x plus sine cubed of x divided by 3 plus the constant of integration.